Well, welcome to Arize Observe. Incredibly excited to have all of you here. Over 1,000 people have signed up for Arize Observe. This is the first observability summit, first ML observability summit in the space, and just blown away by the excitement and interest from teams. And today, hopefully, we'll give you an intro to the subject and then kick off the conference from here. So I'm Jason Lopatecki, CEO, co-founder of Arize. Second-time founder. I built a company previously from garage to IPO called TubeMogul, and at TubeMogul I was the founder who also hired our first head of data science. And at TubeMogul, models controlled over $1 billion of ad spend. They ran our business, and when there was a problem, it was me in the trenches with the data science team. So I personally know what it feels like to try to make models work, make them work at scale, and really just trying to build the software I wish my team had. Let me introduce Aparna.
Awesome. And hey, everyone, welcome to Arize Observe. Super excited to have everyone here. My name is Aparna, co-founder and chief product officer here at Arize. Similar to Jason, also technical background. Myself previously worked as an ML engineer over at Uber, where we put a ton of models into production. And if you've worked in machine learning, you've put models into production, you know how painful it is to troubleshoot when things don't go as expected. And a lot of that personal pain is what got me and Jason to team up and found Arize, and really excited today to kind of launch off this first ML observability conference and hopefully create a community to continue this conversation.
So let's start off where me and Aparna started, which is, as we talk to more and more businesses, we realize every company is trying to be an AI company. Every company is an AI company. And there's a lot of parallels with kind of the early 2000s, where you had every team, every company, and you would never guess this, but every company getting an AWS account, and every company hiring engineers and computer scientists. McDonald's with engineers on staff. You would have never thought that was possible. And today, the same thing's happening with AI and ML. Every company has data scientists. Every company has ML engineers on staff, and they're really trying to solve their toughest problems. And if they don't, their competitors will. They have to do this. And you see this in companies, even a John Deere, 100-year-old tractor company with 1,000 models live. And what this means for these businesses is, as soon as they start to get models out into the real world, as soon as they start to scale that up, they run into the same problems that me and Aparna had. And I'll have Aparna deeper dive into this.
Awesome. Thanks, Jason. So when we first started Arize, we spent, we probably spoke to hundreds, if not thousands, of companies who were doing machine learning. And what we learned was that, to be honest, over the last 5 years that folks have been doing machine learning, the majority of that time has really been before the model even made it into production. It was spent on preparing the data, training different versions of the model, tracking different experiments, figuring out how to even do model deployment, but very little time on what happens once that model actually hits production, actually starts impacting the business. In fact, we found out that less than 1% of time was actually spent by teams once the model was deployed into production. And this had a lot of pretty drastic consequences for those teams. First off, and I personally experienced this too at Uber, was we really never knew when model issues cropped up. It was only when our customers came and complained to us, maybe it was our partner teams, maybe it was actual customers, and they would come and tell us that, hey, it looks like some ETA model was off, or some pricing model looked different, or if you're a fintech company, you're not catching as much fraud, or you're not giving enough folks loans. And so you're actually only finding out about issues when your customers get impacted, and then it can take you weeks to actually troubleshoot and figure out what the root cause is. And as we started talking to more and more teams, we realized that they were facing these very similar business challenges that all had some pretty common underlying technical problems. It was performance degradation, model and data drift, not knowing about data quality issues that were coming in, either in the inputs of the model or either through the outputs of the model, not having tools to really interpret those model results. And in some cases, really drastic cases where those models were making, financial decisions or hiring decisions can really have large scale kind of discriminatory kind of effects, fairness and bias issues. And, these problems, these underlying common technical problems were really tough for teams to actually figure out if they were happening, but were having pretty large business consequences. And so in kind of the grand scheme, what we learned was that companies were shipping AI blind. There's oftentimes a journey that a model has to go through before it even makes it into production. It starts off with a Jupyter notebook where the data scientist is maybe building the model, but then that model has to be transformed, sometimes rewritten into Python, but actually get it to be production ready to be deployed. And most teams typically saw this as kind of the spot where their work was done. But really, this was only 50% of the journey. Once the model made it into production, there was performance drifts, feature data quality issues, regressions happening, and teams were really not that well equipped to be able to troubleshoot these model issues. The best they had, and oftentimes what we heard was, I have a script that I run whenever I hear complaints about my model. And to be honest, it just wasn't a great experience. And so, this is the most complicated type of software we have ever shipped. And yet we're shipping AI blind. And I'll hand it to Jason to share kind of some stats about what we learned from the industry.
So I'll share these stats, which were collected from a survey of over 1,000 companies in this space. 84% of teams, it takes over a week to detect and fix an issue. And that's time you're bleeding money. That's time your customers are complaining and things are down or things are subtly down and you don't quite know it. 51% of teams want better RCA ability on drift. And that was me and my team trying to just get me an answer. 54% of teams say that business execs can't quantify AI ROI. And this is with billions of dollars being spent, can't quantify return on investment. 52% of teams say business execs don't understand ML. I think that number's low. I think a lot more people really don't understand ML than they're admitting, but these are the stats. And let me tell you how teams are trying to tackle these these issues within their business. So there's two ways that teams have gone out to start to tackle AI and ML in their business. One is kind of that first generation citizen data scientist approach, which is a single platform that does everything. And really it's kind of a no code, low code approach to help turn business analysts into data scientists or give people the power to build models who have never built models before. Which is great and which is powerful, but we believe in a different way that's growing very fast right now. And this different way has teams. It's very similar to that internet view where you're now building data science specialty within your business to compete with your competitors, building engineering strength in data science to compete with your competitors, and then using software tools, modular software tools to fix and improve those MLOps workflows and based upon what your business needs. So just like software engineering, you have these modular tool sets and solutions for different problems you have. And lots of teams started off in kind of data preparation. You're spending the last 5 years getting the data great to build a better model. You're building tools. You're using tool sets now to track your training runs, to make sure those models are great. And now you're at that last mile, which is where we are, this production area, this ML observability is needed now because your model's in the real world and you haven't thought much about it. It's the reason 1,000 people have showed up for this conference. The pain is real. And this modular approach to tool sets is not unique. It's very similar in the software space. You have a GitHub and Datadog, which solve very different problems within the software development toolchain. They're different companies, but they're focused. They're deeply focused in their area. They're best of breed. And what you have now is an ML toolchain, a modular ML toolchain developing, arguably faster. It took us 20 years to get the software toolchain, arguably faster with unicorns, big companies in these different focused verticals. And where we are is in the ML observability vertical. So with that, I want to tell you a little bit about how companies are piecing this together. And if you're like me, or like my old company, TwoMogul, you're running into this last mile. You're just starting to deploy your models. You're starting to feel pain when customers complain and you don't know where the issue is. And then you're duct taping software together to get your answers quickly. You're putting Jupyter notebooks in for monitoring. You're putting Tableau in for some quick visualization, BI visualization, and you're connecting Airflow to make it all try to work together. And you're having to standardize and connect all these tool sets and deal with different model versions and adding features and different model types. And it's a nightmare. It's an absolute nightmare. Jupyter notebooks are not designed for monitoring. They are not a monitoring tool set. Tableau is really a miserable developer experience. It's not a developer tool set. And so what ML observability does is it makes this all go away. And I'm going to have Aparna dive in and tell you a little bit more of what this looks like in detail.
Awesome. Thanks, Jason. All right, everyone. We're now at the point where we're actually defining what is ML observability. ML observability is software that helps teams first automatically monitor AI, give you tools to understand how to fix it when it's broken, and ultimately get you to help resolve and improve the data and the models. And observability as a whole has been around much longer than ML observability. You're probably familiar with system or infra observability. And there's some parallels between that space and the ML observability space. In system observability or infra observability, you've probably heard of the three big pillars: logs, metrics, tracing. And they're concerned, really, if you think about the metrics, they're concerned with application timing metrics, server metrics, very different from what we'll get into, which is ML metrics or ML model performance metrics. System observability also has logs, which is really focused on being able to do things like event level search. And tracing is really about kind of tracing the timing of queries through different microservices, different subsystems. And so system observability has been around for a very long time. A lot of great tooling that's been built in place to do logs, metrics, and tracing. And what we're building and really focused on is ML observability. And in the ML observability space, there's some pretty big differences between kind of what has existed for the infra space and what's needed for this new category. Here, metrics actually mean model performance metrics, which means evaluation metrics like AUC of the model, log loss, drift metrics, data quality metrics, really focused on kind of what are the types of metrics that give you information about the performance of the model, and then data quality stats about the model itself. Similar to logs, there's an inference store. And this is actually pretty different from kind of what you're probably typically used to thinking about logs in the infra space. An inference store is really tracking, at the inference level, storing metadata, features, predictions about the model. And so it tracks not just what was the outcome of the model, but also what was the inputs into that prediction. And then later can be joined with the ground truth or additional metadata information that can come. And the inference store also tracks all of these inferences across different versions of the model and across different environments. This is actually a pretty key difference. We're not just looking at production inferences, production logs of a model, but especially machine learning, oftentimes why your model is not performing well in production is really because of the training data that it was built on top of. And so being able to track inferences across different versions and environments is really important to this space. And lastly, the third pillar, which is focused around tracing, performance tracing, is really about being able to link the performance of the model back down to the data that might be pulling it down or might be, might actually be the root cause of that performance issue. And so tracing here is really, still kind of same concept of being able to pinpoint the source of an issue, drill down to what's actually causing it, except the workflow here looks much different than the infra observability space. And let's actually jump into kind of how does this look like in the real world? So before ML observability, teams only found out about ML issues when the business found out. Worse, when a customer found out. And so customer would complain, then it would get bubbled up back to the data science team. Data science and ML engineers are spending weeks writing a bunch of queries, using a bunch of ad hoc tools to figure out, well, what's the root cause of that performance issue? Could it be because I didn't train my model on that type of data? Could it be because I have a data quality issue? But really ad hoc kind of, querying, visualization, and analysis going on without any kind of structured workflows to be able to troubleshoot. And in a new world with ML observability, there's first off metrics that will alert you before a customer even complains. So you'll get alerted that there's an issue. There's troubleshooting workflows using tracing to be able to drill down and root cause. Where is this coming from? What segment is actually pulling down my model? And what's the root cause? Is it because there's an issue with my training data set? Do I need to go back and upsample it? But really walking you down through tracing down the issue to how can I actually go fix my data or fix my model and bring you back down to the inference store to be able to kick off those types of workflows. But vastly different, this troubleshooting, less than 5 minutes compared to weeks of the time that it can take, which means ML engineers and data scientists can feel more confident putting their models into production, have the tools to be able to root cause them, and ultimately have less havoc on your business when ML issues come up, which they will come up. And to summarize, big kind of components of ML observability, there's tools to be able to monitor data quality, performance, drift issues, tools to be able to actually root cause and trace down to pinpoint where is that issue actually coming from, and then tools to be able to bring you back down to maybe compare against training, do A/B analysis, so that you can actually figure out how to go improve the model and resolve the issue. And this is where I need a drum roll from the audience, but for the first time ever, you'll actually be able to put ML observability into practice. We're launching a free Arize platform where anyone can go sign up today from the website. And all of this stuff that we just talked about, you can put it into practice today. You can go, there's a ton of demo models that all the Arize accounts are set up with. You can go dig in, figure out how ML observability can automatically surface up issues, how tracing and troubleshooting actually works in the ML space. And really would love everyone who's attending the conference today to give it a shot, give it a try, give us feedback, give us your thoughts as you're trying out the platform. This is a very new category. It's actively evolving. And folks like yourself, ML practitioners, are what make this category what it is. And so your feedback is massively important. And I'm looking forward to kind of hearing all the comments and hearing all the feedback from you all as you check out an account. And as you're going through this, feel free to connect with the other panelists, other conference members who are here today. There's a number of amazing talks that are here, from top ML companies like DoorDash and Uber and Etsy. And, these folks have really kind of gone through that pain of building ML tools and building ML observability workflows in-house, and really kind of felt the pain themselves. And so, connect with one another. This is the first of its kind of an ML observability conference. And so it's a space to kind of learn, space to connect, and space to share feedback as this field evolves. So thank you everyone for attending. We're really excited about where this is going to go and how this conference is going to change over the next couple of years. And if you have any questions, comments, thoughts, please feel free to reach out to any of us. And thank you so much for attending today.
And I just want to say thank you as well. Amazing set of speakers. Enjoy the conference.